Hi guys, in this video we're going to work on page 546, which is a situation of having no solutions. So please look at the example 3 on page 546. Alright, we are going to solve this system x minus 3y plus z equal 4, negative x plus 2y minus 5z equals 3, 5x minus 13y plus 13z equal 8. Okay, let me check that I copied all down right. Okay, 5x minus 13y plus 13z equal 8. All right, good. So we are going to use Gaussian elimination. We learned in the previous video, right? So what was a Gaussian elimination? We could make a triangular form so that we can find the xyz in an easy way. So for now, I'm going to get rid of my x. So I'm going to label the first one as 1, second as 2, and the third one as 3. So now I'm going to do 1 plus 2. So I'm going to replace my 2 for the answer of addition. So I can keep my first one. So I'm going to do the 1 plus 2. So it will be x minus 3y plus z equal 4. And then negative x plus 2y minus 5z equal 3. So if I add them up, I can cancel my x out. You got I got negative y minus 4z equal 7. Okay, so now I'm going to replace my second one. So that we are going to have this. So I'm going to keep my first one, x minus 3y plus z equal 4. I'm not going to touch anything. Now my second one is going to be replaced as negative y minus 4z equal 7. Okay? Now I wanted to make my last one as a 0, right? So and then I have to keep my last one, 5x minus 13y plus 13z equal 8. So after that, to make a triangular form, I'm going to get rid of my 5x and negative 13y in here. But it seems so hard to get rid of the same variable for both. I'm going to add negative 5 times 1 and add up to the third one, so that it will give us this, negative 5x 15y minus 5z equals negative 20. And I have 5x minus 13y plus 13z equal 8. So if I add them up, then I can cancel my x out, and I'm going to have 2y plus 8z equals negative 12. Right? So let me replace my third one by using the answer which I just got. So keep my first one, x minus 3y plus z equal 4. And I had negative y minus 4z equals 7. And I have 2y plus 8z equals negative 12. Alright, so my goal is to get the z only. So I try to get rid of my 2y. So what I'm going to do is I'm going to times 2 on my second and plus 3. So guys, I just keep labeling my first one as number 1, second one is number 2, and the third one is number 3. Okay? I know that they are keep changed. So this is, I just do number 1, 2, 3. I just, label the same way. So just, pay attention on it, okay? All right. So now it will be this. If I times 2 on my number 2, which is the second equation, I have negative 2y minus 8z equal 14. That's my second. And I have 2y plus 8z equals negative 12. So once you add them up, what's going to happen? I try to get rid of my y's, but you can get rid of z as well. So I have 0 equals 2. Alright, so my final version of this equation is going to look like that. X minus 3y plus z equals 4. I'm not going to touch anything. Negative y minus 4z equals 7. And I have a 0 equal 2. I wanted to leave just z alone, but z just cancels out, and I got a 0 equal 2. Does it make sense? Since 0 equal 2 is never true, we conclude that the system has no solution. Okay? So, I'm going to give you time to work on exercise 5 on page 552. So please pause this video to work on it, and then you can resume the video after you check it. Okay? After you complete it. Alright, so I'm on page 552, number 5. So we also use Gaussian elimination to solve this system, which is x plus y plus z equals negative 3. 4x minus y equals negative 5. Negative 3x plus 2y plus z equals 4. So as I did, I'm going to label the first equation as number 1, second as number 2, and third one as number 3. Okay, so I want you to get rid of let's see which one we can get rid of it first. Okay, I wanted to get rid of my x. Okay, give me 1 second. That is negative 3, right? So I'm going to times 3 onto my number 1 and add up to my number 3. Then let's see what's gonna happen. So we would have 3x plus 3y plus 3z equals negative 9. And you have negative 3x plus 2y plus z equals 4. Okay, if you do that way, our goal is to just show it that, the last one is gonna be z. But if you're gonna do that, we can leave as a y and z. That doesn't really help us. So let me change my plan. So in this time, I just wanted to get rid of my z so that I can leave as x and y. So once I found out that a value of x and y, I think that is gonna be easier. So I'm gonna erase that. Alright, so now I'm gonna do this. I'm going to times negative 1 onto number 1 and add up to 3. I got negative x minus y minus z equals positive 3. I have negative 3x plus 2y plus z equals 4. Then if you add them up, you would have negative 4x plus y, and you can cancel z out, and that would be 7. The reason why I did this is I want you to show it that they have no solutions, because I can see that the xy is on my second equation. So now I can replace my 3 into the negative 4x plus y equals 7. So I'm gonna do that here. So keep everything. X plus y plus z equals negative 3. And then 4x minus y equals -5. You have here now my third one, what we got before. -4x plus y equals 7. -4x plus y equals 7. Okay, see? Then I still label as the first one as number 1, second is number 2, third one as number 3. Now, what I'm going to do is I'm going to add 2 and 3 to cancel out the letter. So if you add number 2 and 3, and then what's going to happen? 4x minus y equal -5. For -4x plus y equals 7. If you add them up, you can cancel out all values of your left side, and that becomes 2. Alright, that's what I want to see, so that I can conclude my answer as this. So my first one, I'm not gonna change anything. Keep everything. And 4x minus y equal -5. Once I see that the 0 equal 2, which is not true, so this equation has no solution. Because 0 equal 2 is not true. It's never true. So you can conclude as this system has no solution. Okay? Yeah, I just want to double check it that I missed anything. Yeah. Alright. Okay, so now I'm going to go back to the page 546 again. And we have a lot of content in here to, solve example 4. So I'm going to spend some time to explain what is the elementary row operations and row incline form. So you guys already did the BPR, right? So you can see that the augmented matrix and coefficient matrix, that's what you need to know first. So there is a given system, which is example 2. So I may use that one again. X minus 2y plus z equals 7. 3x minus 5y plus z equals 14. Now 2x minus 2y minus z equals 3. So first, vocabulary is the augmented matrix. So augmented matrix is, we just pulled out all the coefficients, included our right side. So what I got in here, I got x that become 1, -2, 1, and 7 is gonna be here. So you just bring down all the numbers without letters, okay? And then 3, -5, 1, 14, 2, -2, -1, and 3. That's what we call as augmented matrix, okay? 1, -2, 1, 7. So I just pulled all the coefficients out, and then you just brought down your right side of the equation. That's what we call as augmented matrix. And then especially, if we omit our right hand side of the equation, we call it as the coefficient matrix. That makes sense, right? So those part only that we call as coefficient matrix. All right. So we are going to work on the page 547. So guys, you guys may look at the all the way top. So this is the the work that we already did in example 2. Our goal was what? To make a triangular form so that we can solve this system, right? So you guys may see the augmented matrix on the right side. And the last part, you guys have 1 and -2, 1, 7. So once you are done making the triangular form, that's what we did already, right? We call it as row echelon form. So they have a definition of what is the row echelon form. So a matrix is in a row echelon form if the following conditions are satisfied. So I may use the example with that to explain what that means, okay? So on the page 547, your last part, you guys may see that this positive 1, negative 2, 1, 7, 0, 1, negative 2, negative 7, 0, 0, 1, and 3, right? That's we call as row echelon form. This is row echelon form. Okay, you should remember. So when do we call it as a row echelon form? Number one, rows consisting entirely of zeros if there are any occur at the bottom of the matrix. So look at the bottom of your matrix. They have a 2 zeros, right? Yeah, that is for number one. And then number two, the first entry in any row with non-zero entries is 1. So first entry is any row. So first entry is here. That's number one. And then number three, if column subscript of the leading one entries increases as the row in a subscript increases. You don't even understand what that means, right? So this is this. If you are looking at your first column, so this is my first row and first column. That's starting with the 1. And then the second column, which is the second row and second column. This number 1, we are expected this number 1 and this 0. So, you guys may see that your number 1 is like a, diagonal because my first row, first column, that's number 1. Second row, second column, that should be 1. That is satisfied right here, right? And the third row, third column, that should be 1. So the anything else, which is, when you look at your second row, your first entry is always 0 and your second entry is always 1. It is going to be fixed. Now, when you look at your third row, you should be satisfied with your first 2 values are zeros and your third value needs to be 1. Okay? That's, that if that is satisfied, then we can call it as entire thing as the row echelon form. Okay? So our goal is to take a system of equations, write the corresponding augmented matrix, and transform it to row echelon form without carrying along the equations. So, as I mentioned before, the matrix is another way to representing the system, right? So we are going to, our goal is right now to change our system into the matrix form so that we can work easier way. Alright, so now how can we operate with these? So, we can call it as elementary row operations on a matrix, which is all the way bottom of page 547. Actually, this one we already, saw that on the page 545, equivalent systems of linear equations. That's exactly the same. Only different thing is we just change everything as a matrix. So number one, interchange any two rows. We already did it, right? And number two, multiply all elements of a row by a non-zero real number. Number three, add a multiple of one row to any other row so that we are going to make this form. So, one more time. You are going to have a 1, 1, 1 as a diagonal. First row, first column, that should be number 1. Second row, second column, that should be number 1. Third row, third column, that should be number 1. Now what? In the second column, second row and first column needs to be 0 every single time. And then your third row, your first column and second column, that should be 0. Sometimes you will see that your last one is gonna be all zeros. Yeah, it can happen. But this is what we are going to make it. Okay? So you should remember, which conditions should be satisfied. We call it as a, row echelon form. Okay, so you have to get familiar with this, format. Now, I'm going to use example 4 to show you how we, solve the system, not using the system anymore. We're going to using the matrix instead. Okay, so please go to the page 548. I'm going to solve example 4. Okay, before we start example 4, you should know the notation of it. So please look at the page 548 all the way top left. There is a notation, right? So you should remember this. Number 1, Rij indicates interchanging the ith and jth row of a matrix. So R1, 2, that means you're interchange your first and second rows. Okay? And then now number 2, KRI indicates multiplying the ith row by the non-zero real number K. So simply we just times 2 everything on my, row. One row, which is a RI. And now number 3, KRI plus RJ indicates adding K times the ith row to the jth row. So your answer is going to be replaced your RJ row. Okay? So you should understand those notations so that you can, you understand what we are going to do in example 4. Okay? So I'm going to copy down my question here, which is x minus y plus 2z equals negative 3. 2x plus y minus z equals 0. Negative x plus 2y minus 3z equals 7. Again, our goal is to make a row echelon form, and then we are going to solve this system completely. Okay? So my first step is going to be this. First, I'm going to change this into a augmented matrix. How can we do it? You just pull all the coefficient out, which is 1, negative 1, 2, negative 3, 2, 1, negative 1, 0, negative 1, 2, negative 3, 7. That's how I started it. Now what? My goal is to make a 0, I told you, right? So I'm going to make my 2 into 0. Then what should I do? I want you to make this. I want you to get rid of that to make a 0. What should I do? I'm going to use my first one. So if I times negative 2 onto the first row and add up 2 second row, then I can get rid of 2, correct? So, that's what I usually do not to make a mistake. So, I'm going to show you how I usually do this. So, you have that, right? So, I'm going to use my space above this, bracket, so that I'm going to put my answer of negative 2 times R1 on top of here. So 1 times negative 2 is going to be here, negative 2, positive 2, negative 4, and negative 6. Now I'm going to add up to my second so that I can complete my answer. So you can just keep your first one samely. Now you have 2 and negative 2 become 0. So you are literally working with this row and this row so that I can get my new answer right here. Correct? So 2 plus negative 2 becomes 0. And then I have 2 plus 1 become 3. Negative 4 plus negative 1 become negative 5. And negative 6 plus 0 become... Oh, I'm sorry. That should be positive 6. Positive 6 plus 0 become 6. So I got 0, 3, negative 5, 6. That's my second row. So always your R2, if you have a negative 2 times R1 plus R2, the answer is replaced onto your last one, which is the second row. Now you are going to keep the third one samely. Negative 1 here, 2 here, negative 3, and 7 here. Okay? Now, what should I do to get my second? So now, my goal is to get rid of my third. This one. I want you to get rid of that as a 0. So, I'm going to I'm going to add my first and third so that I can replace my third as the answer of the addition. So I'm going to write down as this. If you add first row to the third, then you don't really have to write down this time because you don't really change anything, right? You just literally add them up. So keep your first. Nothing changed. Second, nothing changed. Third, 1 plus negative 1, 0. Negative 1 here plus 2 here, which is 1. 2 plus negative 3, which is negative 1. Negative 3 plus 7, which become 4. That's my new answer. Okay? So, erase those dots. I just want to show you. Okay. I just keep that. Now I'm going to next. All right, so my goal right now to make this number as 1. So here, when we are looking at the row echelon form, then my second row, second column, this number needs to be 1. When I look at all my augmented matrix, I found out that, oh, that number is 1 right there. Or simply, so I can do simply that, you know, okay, that one goes to here, okay? Simply, I just change my second and third, then it will be good, right? So you can just put, you know, interchange second and third, then I can make my second one as 1 without doing anything. So your first one should be kept. To negative 3. Now switch up so that I can simply make my 1 here. So I already made a 0 and 1 satisfied, 1 satisfied. So my goal right now to get rid of 3, correct? So how can I get rid of 3? Well, I can work it. You can times negative 3 onto your second one, add up to the third. So that I'm able to get rid of my 3. So this time, okay, I'm going to have a space a little bit down here, okay? So now, you can write down the answer of negative 3 times R2. That would be 0, negative 3, positive 3, and negative 12. That's what I got, right? Now what? Keep my first one. Keep my second one. Now, I'm going to add 0 and 0. That would be 0. Negative 3 and 3. That would be 0. Negative 5 plus 3. That would be negative 2. 6 plus negative 12 will be negative 6. Okay. Is it look like a row echelon form? Not yet, because my third row, third column, this number needs to be what? 1. So, what do I do right now? You are going to times non-zero value to make that. How can I do it? If you times negative half onto your third line, which is a third column, then you can make negative 2 as 1, correct? So, everything has to be the same. Everything has to be the same. By the way, this is my 2, guys. Okay, I'll write down. Now what? Times 0 times half is 0, which is negative half. 0 times negative half, again 0. Now, negative half times negative 2 become 1. Negative 6 times negative half become 3. That is my row echelon form. Alright? Is it satisfied with what we just learned? Yes, it is. What should we check it, guys? Here. 1, 1, 1, 0, 0, 0. And it looks perfect. Now what? the last matrix we call as a row echelon form. So then we convert each row into equation form and complete the solution by substitution. So we are going to learn how we can how we can get into the easier way. They don't really introduce you yet here. Oh, they do. Reduced row echelon form. We're going to learn in the next video. So that is the best way because you can really get your answer right away. But for now, just row echelon form, we are going to stop it here. Okay, now we are going to replace everything back to the system. So I have a x minus y plus 2z equals -3. I have y minus z equals 4, z equals 3. So now, what should I do? I'm going to substitute my z as 3 for my second, and then you would have y minus 3 equal 4, y equals 7. So I got my value x equals 3, y equals 7. Now what? How can I get my x? You have to replace everything back. X minus 7 plus 3 equal -3, which is 2 times 3, which is 6. Now x minus 1 equal -3, x equal -2. So I found all my answer, which is x equal -2, y equals 7, z equals 3. How can you represent your answer? We are using order triple, which is -2, 7, and 3. All right? Okay. So now I want you guys to go to the page 30, page 552, number 30. What number was it? Number 33. Yeah, number 33. So please solve that one first. After you solve it, please check your answer with me, okay? Alright, so I'm going to show you how to do this one. So I have a x minus 2y plus z equals 8. 2x plus y minus 3z equals -9. And -3x plus y plus 3z equals 5. And you may have a question that, oh, Mrs. Kim, my answer is different as yours. It could be because you guys have a different order to do. Sometimes your order got messed up, which is a different order. Still, your row echelon form would be the same, but you're in the middle of it. Yeah, it could be different. So as long as your final answer would be okay, then all the works are satisfied, which is makes sense. Then you will be good. Okay. So now my first step is to write down as augmented form, which is 1, -2, 1, 8, 2, 1, -3, -9, -3, 1, 3, 5. Okay, now what? As we did already, I already get rid of my 2 here. So I'm going to do -2 times R1, and I'm going to add up to R2, which is my second row. And then, so if you times -2, you would have -2, 4, -2, -16, and you just kept your first one samely. And second one, you are going to add together. So -2 plus 2 would be 0. 1 plus 4 is 5. -3 plus -2, -5. -9 plus -16, -25. And last one, keep it. Now, what do we do? Okay, so my goal to get rid of my third one, right? So let me just use this. Again, my goal is to get rid of this one. How do we do it? You just times 3 onto your first one and add up to the third. Then you can cancel your -3. So I will do 3 times R1 plus R3. Okay? Then if you times 3 for the first one, what did you get? 3, -6, 3, 24. First one, we don't change, we don't touch anything, so keep it, which is 1, -2, 1, 8. Now second, keep it same. And my third, 0, -5, 6, 29. Are you guys with me? Now what? My goal is to get rid of this. I want it to make into 0. Some of you guys may think about, oh, can I divide by, 1/5 to my second row to make 1? You can do that if you want to. So I told you that your, order maybe got changed because of that. So it will be fine. So for now, I would do second and third. I'm going to add my second to third so that I can cancel that one out. Your answer may be different as my answer. I told you already. So if you add your second and third, your first one is going to be same. Your second is going to be the same. Now your third is going to be 0, 0, 1, and then 4. Right? Now my next would be to deal with this. I wanted to get rid of 5 to make 1. So easily I can just divide it by what? 1/5, right? Then I would write down right here. So if you times 1/5 to your second row, and you would have this. 1, -2, 1, 8. 0, 1, -1, -5. 0, 0, 1, and 4. All right, so that's it. That's my, which is my row echelon form, right? Because it's satisfied with this 1, 1, 1 here and 0, 0, 0. Okay, so, after that, I'm going to change everything back to the system form, which is the equation form. That would be this. X minus 2y plus z equals 8. Y minus z equals -5. Z equal 4. So, as we practiced already, replace your z as 4. So you would have y minus 4 equal -5. And your y would be 1. So you got your z as 4 right here. You already got it. And your y equal 1 is here. Now how can I get my x? Plug your y and z. So x minus 2 times 1, 2, plus 4 equals 8. X plus 2 equals 8. And your x would be what? Oh, wait a second. My y is -1, right? Because plus 4, -1. So, which means I'm having 2 here. That will be 6. So -6 and my answer x would be 2. Okay? So how do I represent my answer? Ordered triple. 2, -1, 4. That is my answer. Okay? Alright, so I hope this video helped you, and we're going to see you in the Zoom class tomorrow. Bye.